Greetings, everyone, and welcome to this podcast or presentation that we're going to be having over scalable modeling. Here we have the actual creator or the one who proposed this solution to multiple problems that we have within the software development, software architecture um, process, Simo Roikonen, and me, myself, a student of scalable modeling, Jose Hidalgo. Um, so let's go ahead and start. And Simo, what is scalable modeling? Why do we need scalable modeling? Where does this all come in, or how did this happen?
Yeah, good question. And nice to be here, by the way. The reason or the background for scalable modeling goes a long way. So I have a pretty long history in the distributed systems, scalability and resilience. And I think it originates already from those times more than 10 years ago when I started doing work with distributed systems. And I kind of discovered back then that it's not easy. The distribution is making things quite complex. And doing a creation of distributed systems as a teamwork requires, of course, the collaboration and capabilities to design these systems so that we can implement them as a group work, taking into account all stakeholders. So it's not only the developers who are implementing the distributed systems, but there are multiple stakeholders from the business to domain experts to the designers, and of course the developers as well. And I kind of struggled with the distributed systems and how to design, how to implement them. And over the years, I have found different already made practices that help creating distributed systems and designing distributed systems easier. And the scalable modeling is not something new. It's based to already existing things. But I kind of wanted to formalize those good things into a, let's say, my personal opinionated golden path that describes the components that are good for creating distributed systems that can handle the growth. So these kind of growth-ready systems. And it also defines a approach how to collaborate when you are creating growth-ready distributed systems. And this whole approach has kind of evolved from the distributed systems into more towards growth readiness. So you don't always need distribution, you don't always need scalability or resilience, but it's important to still consider those things and try to make the system to be growth ready. So if the system becomes successful, you need to be able to scale the system without complete rewrite. You need to be able to implement the resilience or improve the resilience in the system if the resilience is needed. Usually that also relates to the success. And also the domain evolves over time. So the scalable modeling approach takes that into account, that when you are building the systems from these building blocks, these systems are growth ready in the kind of the terms of all three, so scalable, resilient, and evolvable. It tries to address those by providing this opinionated way of creating those systems. So in a nutshell, it's about that. I could also show this picture here. So this is if we don't think yet about the scalability and resilience, only about the way of how to implement systems, not only growth-ready systems, but all kinds of systems, not only software systems, but really all kinds of systems. It usually starts by understanding that why do we need such a system? Who needs it, and what problems does it solve? And that is usually clear for the business owners, the domain experts, more or less. But then the developers, they are more interested about how to implement those systems. And it tends to be, according to my experience at least, that there is a bit of a broken link between the why and how, oftentimes. And what is the conceptual model for the solution? That's something that the scalable modeling tries to address. So scalable modeling is also a meta model for building the conceptual model that is easy to understand for the business owners, the domain experts, and it's easy to understand for the the ones who are implementing these systems. So it's building a bridge. It's a conceptual model that can be worked together with the domain experts, with the developers. It is somewhat easy to understand for the domain experts, and it is building a path from that model to the implementation of a growth-ready system. We can use the same components that we use in the conceptual model. We can use those also in the implementation. Maybe that's the not so short summary about the scalable modeling.
But it does give you like good ideas to the why, and I think we can even use the same image to go over this conversation between. Okay, so why is a scalable model needed right now? You mentioned that scalable modeling was made out of the pieces or parts of different techniques or approaches that you have experienced throughout your works and throughout your career. Can you go over a bit of what are these pieces that scalable modeling is made of?
Yes. I think we could maybe approach this through a small presentation. And I will start from the concept of a system. So we will start from really high level. System. What is a system? That starts building the bridge to the scalable modeling. So system, of course, there can be multiple opinions, and I bet there are, but this is one way to look at it. So system, from my point of view, consists of a set of processes and a state or states. So there can be, of course, multiple states, especially if it's a distributed system. And if it's a growth-ready system, you kind of need to split the state into pieces so that you are able to distribute it if the need comes. So my definition of system is that it is a set of processes that are evolving the state of the system. And the processes are kind of temporal, meaning that they are relating to time, sequence or duration. They are kind of flowing in time. Sometimes these processes are also doing these kind of backflips. I don't know what to call, but they are going back in time as well. So processes are not only going one way in time, but sometimes they need to also go back. So there are these loops in processes as well, which make implementation of a system, of a growth-ready system, a bit more challenging. And when the processes are temporal, so time-related, the state, it's more a spatial thing. So it's the state or the states in the system, they are always connected into a physical location, basically. We can think we can also relate this to humans. So I, as a person, I have my internal states. It's it's a space, so it's here where I'm now sitting, and Jose has its own state as well. And if we want to form a system together, we need to have some sort of a process that evolves our states and make it kind of eventually consistent. So the states, they are connected into space. And because we want to distribute these is sometimes problematic in these systems. But overall, we need to connect the time and space when designing the systems. We need to have processes and these kind of entities. And the traditional way, I would say, how to design systems, which kind of building blocks are needed to build systems of processes and state, consists of 4 elements. So if we start the simplest one, well, it's the state. It's the state of system or partial state of a component within a system. And we want to change the or evolve the state of the system through processes. And in the building blocks, we have this thing called policy. It's a bit of used in multiple places, the term, but I use it here to describe a business rules that either allow or disallow altering the state. So they are the domain rules, the let's say we could call it even a business logic. So when we send in a command that requests modifications in the system state, those commands are processed through policy, which verifies usually the command against the state, and then either allows or rejects the command. And if the command is allowed, the state is evolved. And then we have also the queries, which we will use to query the state. Maybe even more traditional way would be that we would just have requests that are modifying the state and querying the state. But I think that the CQS is something that nowadays is very much accepted as a starting point. So we need to separate commands and queries to make the system more evolvable. So the starting point is this. But we are actually missing one element. There is one ingredient in the scalable modeling that evolves the growth readiness.
Yeah, I remember you calling it the 5th element.
Yeah.
Yes. So we have the command, which is, I guess, the what needs to be executed or whatever it is that we're looking for. We have the policies, which is kind of like what limits how much of the command or what the command needs to be executed or to affect the state or to obtain something from the state or to change the state itself. And also we have queries, which I wonder, this is a question here for me. Can the command in itself also, and the policy also go to the query? Like there's some queries that we can execute only if they meet a certain policy. Similar to that.
Yeah, there is a this use case, and actually in the scalable modeling approach, there is a thing called a gatekeeper. And so the command handlers as such in this structure, they don't do any queries. But if we have the need, let's say, can I come quickly with some actual example? Let's say, for example, that we can only create order for customer if the customer has been registered into system. So in that case, we would be able to basically need to first take in the command, then ask if that customer in that command has been created to the system. And if that is the case, we would create the order for the customer. We could use this component called gatekeeper here. So command comes, the gatekeeper goes and it consults a query, a true query, a state of the customer, and checks if the customer has been created. And if it has, we can then let the command go to the actual command handler that is creating the order. And why it needs to be so complicated? Well, basically, we are dealing with two different concepts from two different contexts. So we have the users and we have the orders. And usually those two things are not within the same system. So we need to have this gatekeeper to verify that the customer exists. And now we could go very deep into this, but I will continue a bit and say that the arrow here is red, and it says that we should use this with caution, because in distributed systems, it is possible that if the customer can be removed from the system, the command may come in and we will verify that the customer exists, and we let the command go deeper into the system of the order management, and the order is created, but in between all of these, the customer was removed from the system. So now the system is in inconsistent state. We have an order for a customer that doesn't exist. So that's why the arrow is red, and we should create the flow of customer management so that the customer is never at least immediately removed from the system, so that these corner cases can be handled. There are multiple patterns to manage those kind of corner cases when different parts of the system are modified at the same time, and it is causing conflict. So there are these conflict resolution patterns, but I won't dive into those yet. But basically, to answer your question about that, can command handler access the state? It can accept the state of its near entity. Let's say that the send order command can accept access to the order entity, but it cannot directly access to other entities in different contexts, such as a customer. And for those accesses, we need to have these gatekeepers that are doing access to the other parts of the system, other contexts, and when they get the results, those results are not necessarily any more up to date, because we are talking about a potentially distributed system.
Thank you for answering my question. I actually was starting to think about, I wonder. Now, let's go back to that fifth element, which
yes,
is left to be mentioned here.
Yes, let's reveal what it was. So I will jump back there. So yeah, so we had these four elements normally used in creation of a system, maybe even to model the creation of the system. But the fifth element, something that we need to have in a system that is growth ready, it's the event. And it's an interesting, the whole concept of an event in traditional, let's say traditional, for example, CRUD-based systems. The event is not explicit in these systems. It may be implicitly there present, but the fact that when we are raising the event as an explicit member, equal member to these four, that automatically starts guiding the implementation towards a growth-ready system. There are nice features in the event. Maybe we will start to first discuss that what is the event actually in this context of scalable modeling. So the event is a fact that has happened in the system. Therefore, it's immutable. So when these facts happen, they cannot be changed. And it, of course, brings some challenges because if there are some things that you cannot change, it may make things, at least when thinking those, a bit harder. But on the other hand, it's also like that in real life, that when you have done something, you have created events, like, for example, publishing this video, especially if we publish it to internet, there's no going back. So event is the same. But what we get with this event is amazing distributability. We can also distribute this podcast. We can make copies and distribute it as how we like. And it's the same with the events. When we have these immutable facts, we can send them to different parts of the system and make those parts to be eventually consistent. Of course, it takes some time to send these events, but through the immutability, we really can make the system to be distributed. And also, not only the scalability and resilience that is achieved through distribution, the events are also key to evolution. So as an example, when an event happens, we don't necessarily know when we are starting to implement a system that if this event is useful or not. If we are creating root-based systems where we are basically reading, modifying, deleting stuff, and then later on we notice that, hey, this thing that was deleted, it would have been nice to know that how did it live in its system before it was deleted. For example, to create some analytics, some decisions based to these historical things that did happen, but we didn't record. With the events, we already have the things, every fact that happened in the system in our history, and we can leverage those events also in the future. So even if we don't know that we need some events when we are storing those events, we are able to leverage those events in the future when more functionality, for example, is needed to be implemented to the system. So that's how the events are also enabling the evolution of the system better than systems where the events are kind of implicit things in the process.
It's interesting. Now that you mentioned how like sightline events have been in most of the way we do development, and I can speak from experience that I have also seen that events are just a means to an end without putting so much emphasis into how important they are. You know, even when it comes to algorithms, right? Like what algorithms describe is it's how to accomplish a task or from beginning to end, and how the state changes in between whatever is it that we're doing to some sort of data or an element or anything like that. And events are the key thing that makes us understand the context of how everything comes to happen, where does everything originate. We can see that through history. We can see that through the way we manage businesses and how a business can become successful or not. There are a series of things that are important in the timeline of things, and event is the key element that allows us to understand the entire timeline. and I can see how that fifth element that comes into this picture that is proposed through scalable modeling, at least to someone who's just looking at it from the outside, it makes it way more readable, I think.
Yes,
Yeah.
that's true. The thing is that it's still fifth element on top of four existing elements, so it kind of makes it at least 1/5 harder to implement systems that are using this element. So many times this event centric thinking is considered to be harder than just considering those four elements and building systems on top of those. And I guess there is some truth also there that it is definitely easier to implement systems with just these four elements, or just with request, some sort of a request handlers and the state. It's easier, but I think that the reasoning why we are building systems, at least to more complex systems, is to build them to grow, to become successful. And according to my history, I have noticed that the most projects where I have worked are relating to a modernization of systems that have started by using these 4 or 3 base components. And those systems have developed to a state that modernizing them is really, really complicated. And it's easy to see that if this fifth element would have been present in their initial design, the modernization probably would not even be needed. And if there are some, let's say, technical reasons why the modernization would be needed, it would be much easier, as we would be able to stream the system events to a new component in near real time that would take over the functionalities of the old component. So I would argue that if you are starting to implement a system that is non-trivial, where there's a potential for success, for growth, I would personally encourage to use events as building blocks in the design and in the first implementation as well. It's not too hard when you grasp the mindset how to leverage events as part of your other components.
Thank you for that. And yeah, I definitely agree with that. And going back to this why, what, how, what is it that scalable modeling is actually seeking to solve or address, or um, which gap is it trying to fill in the software development life cycle? Or
Yeah, I would say that the gap is to provide a opinionated but functioning a golden path to design growth-ready systems and a toolbox of components for implementing those systems. So it starts from the very beginning, from the why, and it ends to how, by providing a toolbox of the building blocks, how to implement those, and the rules between those components. So even though it's not providing any concrete technical coding libraries or things like that, it provides the rules that allow you to implement an application that is evolvable, scalable, and resilient if the need comes. And the difference, you easily start thinking about over-engineering, but the difference is that this aim to avoid over-engineering. And that's also very interesting point. So how to build systems that are ready for scalability and resilience, that are evolvable when the domain evolves, without over-engineering. So the only addition to scalable modeling is the events, the existence of events. And I'm again arguing that the adding the events to your implementation from early on, it's not over-engineering. So it's if putting this into a nutshell, it's providing a methodology from the problem to a solution that allows scalability and resilience and evolution when the need comes, by getting into results quickly without over-engineering and iteratively. And now I need to also add the thing that I didn't mention, but it's of course crucial, and it's also in this picture. So the iteration. So even more important than everything in the scalable modeling is that we aim to do quick iterations. So we can do that with scalable modeling, but it is more important than anything in the scalable modeling that we iterate quickly, so that we start from the why and we create conceptual model, which is fairly quick to create together with all stakeholders, and we can quickly iterate that already on the conceptual level, which saves us a lot of time, because as soon as we move into implementation phase, it takes much more time to implement these models than what it is to work with those models on a conceptual level. So first we iterate quickly the conceptual model together with all stakeholders. And then when we have iterated it to a level where everybody is more or less happy and they have gained the common understanding, they know the common language of the problem, what DDD calls ubiquitous language, and they know the structures and the processes, kind of the state and the processes, they are ready to move to the implementation phase. And of course, it's impossible to take everything into account in the conceptual modeling level. So in implementation level, we will also discover new things, and we will need to iterate also the implementation. But it is higher, it comes with a higher cost. So the key fact that I have not highlighted enough in the scalable modeling is that we need to have fast feedback loop and fast feedback loops early on.
Yeah, I can see how that can get expensive, time-wise, resources, on the long run. If we don't, like, in this slide, the detailed feedback, the detail, um, hopefully well discussed implementation that will be executed. Yeah. All right. I guess this will take us to a more in-depth discussion on how is it that scalable modeling seeks to address these deficiencies, these issues, or maybe um, improve or the current way that the system design and development it's being handled.
Yeah. Yeah, I think there are multiple different ways that we could approach the how part, how to explain it. I can just start by vocally first. So the how, I think it's good in this point also to jump to visit here. So there is a web page called it's in roikonen.github.io/scalable modeling that you can find more information what is scalable modeling about. And the why part, it's mainly encapsulated in the modeling methodology. It shows different things about how this happens. It's the event-centric. The event-centric is one of the keys in scalable modeling. It shows the components that there are in the modeling. So if I shortly explain how the scalable modeling process works, we can then maybe later on also move to an concrete example, because the concrete examples are usually better. So the scalable modeling starts from events. So usually, of course, it starts from the problem. There is a persons, organization, something that has a problem, and that problem relates to a group of something, people or something. So somebody needs a solution for a problem. That is something that is before scalable modeling, but scalable modeling helps to iterate the problem, because it oftentimes is that when, let's say, in organizations, people think they have problems, they are actually trying to optimize those problems in their own bubble without seeing the bigger bubble, the system of systems. And sometimes when these people are optimizing their own bubbles, they are optimizing the wrong things. So by starting with, and now I'm using the term event storming here, because scalable modeling is the beginning of events. The beginning of scalable modeling is based to event storming. The event storming is something that helps the problem owners to iterate their problems, to move them to kind of model the problems, their processes, the big picture, together with other stakeholders around the problem. And in this process of event storming, they may actually notice that the problems that they started with are actually not the root causes, but the root causes are elsewhere. And through the event storming, the real problems are appearing. So the scalable modeling starts from event storming. It's actually, the event storming is not fully part of scalable modeling. Scalable modeling is more on the tactical part of event storming. And in the event storming, there is also the strategical modeling and the process modeling levels that I would just guide to learn from the event storming methodology. And you can start by doing event storming or other kind of domain discovery to make sure that your problems are the root causes, not the consequences. But when you have done that part, you have modeled your processes that you want to implement, those processes that help you to solve the problems. We will move into the strategical design phase. And that's where the scalable modeling building blocks jump in. So we can start first from events, such especially similar to the event storming, which also starts from events. So we can, similarly to event storming, start putting those events into a timeline to create those processes that may already have been created in the event storming process level storming phase. So we start still from the empty canvas, and we put those events in and move from there. After we have put those events into a timeline, we can also add those policies there that are affecting to the events. And somewhere there in between, the scalable modeling does not strictly enforce any order, but somewhere in the beginning you also formalize a first version of a ubiquitous language, meaning that you define the terminology of the domain, the things that you are, the terms that you will be using, the terms that you agree with the domain experts, the terms that you will be using in the code and in the modeling. So you will make a common language which makes your communication a lot faster. And from there, when you have the events, you have some policies, you have ubiquitous language terms, you continue by adding commands, queries, users, views, and you work with these components on a whiteboard. You can work with those components live by using Post-its or remotely by using digital whiteboards, and you will move on until you are in a point where the timeline is not sufficient anymore. So in somewhere you start to notice that, hey, there are these back loops in your timelines. And that's usually the point where you need to move from temporal time-based modeling with a timeline into a more spatial modeling, where you actually start having arrows going backwards in the time. And this all is iterative process. You will keep doing it together with the domain experts, with the developers, with the designers. And after all, you will be coming up with a model where you have commands, you have states, you have events, you have queries to those states, and the arrows, of course, between those. You may have external systems and all of these components that are explained in here. And when you have that, you are having the conceptual model. When you agree with that model, with the domain experts, with the developers, you can start translating these models into an actual implementation. So in a nutshell, that's the how, but it's of course better to see it in practice because it's really hard to explain just vocally.
Yeah, I can see it can get very complex to go, even to zoom out from it. But it's certainly made of different different pieces with a intended purpose, and I think that maybe when we speak about it, it might sound complicated or complex, but ultimately it's not. It's probably something that everyone, to some extent, is doing, but has not paid attention to how important it is to refine those pieces, right? That make the whole. Yeah. So for what I can see, this how scalable modeling solves some of the issues that we have discussed here. It's not just adding the event. It's not just adding the fifth element to it. It's a whole strategy or strategic approach to developing scalable, resilient systems.
Yeah,
Okay.
exactly. And it's kind of if I list what it's built on top of, because it's just a layer, opinionated layer on top of existing things. So I already mentioned the event storming, which is a methodology. How do you collaboratively create storm together about problems? You create a processes, you discover some gaps in your knowledge, in your processes, you improve it, and the event storming is kind of initiated from the domain-driven design. So, for example, the term ubiquitous language that I mentioned, it's coming from there. So the domain-driven design is also the thing that this is based to. The CQS, I mentioned the command query separation, but it's also, this is very close to CQRS, the command query responsibility segregation, where the query and command handlers and also potentially the models are separated from each other. And many times when you have separated the command and query model, you need the events in between so that the projection from the command model to query model works. So that brings the event sourcing into picture as well. So this is building on top of these things, and it also makes it easy to have a clean architecture approach. But that's also really hard to explain vocally. It comes better with an examples.
Which we're gonna be looking at in the next chapter or episode of this discussion or podcast.
Exactly. We are going to have a really nice case that we are going to solve with scalable modeling, and that hopefully will make it very clear what scalable modeling is all about and how efficient it can be. So, okay, I think that's all for this time. We are already working on our next video where we will be hands-on with the scalable modeling and do also a real coding examples from the results of those scalable models that we model. Meanwhile, you can subscribe us in YouTube in the Scalable Modeling channel, and also follow us in the LinkedIn in Scalable Modeling public group. So thanks all for watching, and see you next time.
See you. Thank you.